he's going to discuss with you, of course, his specific technology of paper reality and virtual reality. Right. So before we begin, please make sure you put your headsets on. We do have a live presenter coming in through Zoom here, and there's headsets for everyone. So if you put your headset on, he will give you about a 10-15 minute presentation. And of course, you can ask any questions after the presentation.
You are here as well.
Nice meeting you, Sonny.
We've never seen this. We never seen this before.
Couple of times.
Yeah, no, never. We never seen this before.
So there's some new stuff as well.
There is.
Okay, yeah. You have to tell me more.
There's a pretty cool one, HoloLens with Alex.
Hello, everyone. Can you hear me all right?
Yes.
Yes.
Can you hear us?
Please tell me when you're ready.
I cannot hear.
Yes, I think it's on
It's mute.
Yeah, I think I don't know. I don't think it's that screen.
Please tell me when you're all ready, okay?
Okay.
Yes, we're ready.
We're ready.
Put on mute.
We are ready. Sanchi, we are ready.
Yes, please.
We are ready.
We're ready. All right, ready to go. So, good morning, everyone. This is Diego. I'm talking to you from Spain. We're going to be talking for the next 10 to 15 minutes about 3D printing. It's one of those exponential technologies that it's still on the deceptive phase. But believe me, things are changing really fast here. So we're going to do 4 subjects. We're going to have a fast technical overview. We see major applications, a little bit of the business and market opportunities, and some open questions about the future of 3D printing. And we're going to jump directly to the technical overview. 3D printing, also known as additive manufacturing, is just a process of printing layer by layer any 3-dimensional object based on a digital file. It was invented around 1983 by Charles Hall. He was a co-founder of 3D Systems, and he started this whole process, this whole technology, inventing the stereolithography. That was precisely the first commercial 3D printing method, but today things have changed dramatically. We have up to 9 different technologies comprising the 3D printing marketing, and they are very, very interesting. Due to time constraints, we're just going to see some of them, some of the most popular and some of the most interesting. But again, there is like a huge variety, and we see every other day a new technology popping out. One of the most known and commercially used technologies is the material extrusion 3D printing. It's led the market growth through 2017 to significant consumer adoption. This is what we will have at home typically. But there is many other technologies that, like this one, the clip technology, continuous liquid interface production. This is like really amazing to watch because it's like the whole product is emerging from the liquid. It's something really to take a look at. We also have these pretty cool technology, the 3D printing pencil, with which some artists are doing amazing stuff. It is just a quick picture of a part of a car that was completely raw with this 3D printing pen. But we have other interesting technologies. We can now cold spray matter into another product, so we can have like an additive technology based on a spray. We also have anti-gravity 3D printing, very nice, and we even have a zero gravity 3D printing. There's a startup that actually comes from Singularity University that was the first to put the 3D printing on the International Space Station, and it makes a huge of a difference because just sending 1 pound of payload into orbit is about $10,000. So they're very excited about the use of being able to produce tools locally. We're going to jump very fast into 3D printing materials. Right now, we have up to 250 different materials that can be 3D printed in full color, from titanium, rubber, plastic, glass, ceramic, leather, even chocolate. New materials are 3D printed, that can be 3D printed are announced pretty much every day. and the latest generation of 3D printing can even print several materials at the same time, and that opens a whole new spectrum of opportunities. Actually, it's really hard to think of a material that could not 3D print in theoretically. Given the right circumstances, nearly any material can be 3D printed. We're going to see some very fast examples of jewelry in industrial medical applications, for waxes, but also for plastics or ceramics. We see pretty much all metals are right now possible to 3D printing, to be 3D printed. And there is like a very growing interest on the metal 3D printing for product designers and engineers, because it seems to be delivering all of the potential that 3D printing has in store. In space exploration, for instance, this is making a huge difference in SpaceX, Elon Musk's SpaceX and NASA, because they've fully embraced this technology on the way they produce rocket ship parts, and they've dramatically lowered the cost while improving performance. We also see liquid metal 3D printing, and this is pretty amazing, and it holds a promise for a revolutionary manufacturing method for stretchable electronics. See, you could now print electronics. You can combine the board printing with a metal printing, and without even have to change the machine. This mixture doesn't come cheap, though. According to new scientists, it'll be like 100 times more expensive for now to 3D printing in metal, liquid metal, than in plastic. But we're going to get there. You can also, and this is very interesting, 3D print lunar and Martian dust. This is amazing, again, for making tools, but also for making shelter. We are seeing a boom in the 3D printing food. You can just program the 3D printing and have your dinner ready 3D printed. There's one company that is leading this whole process that is called Foodini, and they introduced a natural machine on Kickstarter in 2014, and since it seems to be taking off. You can 3D print your pizza, you can 3D print pretty much whatever you want to. And I mean, it's still not awesome in terms of results, but it's opening new doors to completely new development. But you can also 3D print concrete, and we'll see in a minute that houses have been 3D printed in a completely different manner than we do traditional construction. You can 3D print biomaterials. There is a company headquartered in San Diego that is been at the forefront of 3D printing research from some time now, and it's called Organovo. Not only do they currently bring revenues in providing pharmaceutical companies with their technology, but they also applied it to drug toxicity testing. So it's something to really take a look at. We're going to now jump to some major applications in 3D printing. We're going to see some of the most recent applications that have been observed. They've been demonstrated across many sectors, all from aerospace to medical and to biotechnology and food production, as we mentioned. This is actually the current distribution of industry spending. We see that industrial design and architecture are still leading the way, and we're going to see why right now. In industrial design, 3D printing is promising a boom, like a spring on the way we do things, because see, this technology brings possibilities that were completely impossible in the past. And I'm not going to talk. I'm not talking only about creating an object out of nothing. I'm talk about creating complexity. Now, thanks to 3D printing, we can just go as complex as we want because complexity is free. We can, in architecture or in product design, we can make the structure become the facade, or we can use the minimum shape, maximize the weight load, and maximize the structural load capability while we minimize the weight. So we are seeing a completely new breed of industrial designs emerge, and the prototyping is now getting free too. See, if you look at these shapes, they look like much more organic, and they are much more efficient. These, if you want to look at it, it might remind you as the Tour Eiffel. The way Tour Eiffel is proposed is similar to what this automated design is doing. It's again a little bit like the bone structure that we have in our bodies. So see, this is when things really start to get interesting. This is an example of a seat frame done by Autodesk that is much lighter. It's done in magnesium, and it's much lighter than the previous seat frames. It's done using generative design, and it's apparently over 35% lighter than the aluminum that is conventionally being used, and 56% lighter that you'll typically find in any other airplane. So Autodesk recently designed this super light airplane seat frame, and the design is expected to be saving over $200 million a year. So it's on the overall lifetime of the aircraft. So it's a huge amount of money what we are talking here, and this concept of the generative design is probably going to be the most important of this whole presentation, because as I'll explain to you in the future, so in the next minutes, we don't have much of a future here. This is going to free completely the full potential of the 3D printing. Freeing and automating the design process with the generative design is going to allow us to use the full potential of the 3D printing technology. So in manufacturing too, if your customers, or your customers are in the business of making anything, 3D printing is on the road to disrupt your industry and your business. It completely transforms the entire manufacturing process. Customization and complexity comes for free, and large-scale custom manufacturing is no longer a problem. Additive manufacturing also saves tremendous costs in terms of material, requiring as little as 10% of the raw materials expended in traditional manufacturing, and eliminating the need for inventory, which is something pretty interesting too. We see now that it's reaching the consumer market. We see also that many brands are jumping into this. Adidas is mass producing 3D printing shoes using the warm liquid goo. It's very interesting. And what happens here again is that the prototype might be exactly like the final product. There's no need to retool. So we also see that it's been applied in construction. The next phase of 3D printing is moving things to really a big scale, as big as a house. These houses were 3D printed. Some parts were not, but according to the company that did it in China, the labor needed to 3D print this building was 80% less, and the material savings were 60% compared to conventional home building methods. They 3D print 10 concrete houses in 24 hours. So it is a game-changing technology. This capability unlocks billions of dollars in industrial applications for 3D printing, and aerospace is one of the most interesting ones. We see that North Titanium partnered with Boeing, and they're saving up to $3 million per plane. So, you know, aerospace, aeronautical industries are one of the main larger applications that we see thriving in this for this technology. But we also see that it's been applied to medical, and it might disrupt the traditional approach to many of the medical activities that we do. The transportation industries are probably one of the most sensible to these new technologies. 3D printing could threaten 41% of the air cargo, 37% of ocean container, and 25% of trucking freight business, according to a report last year from a consumer firm. It's also jumping to automotive industry. Right now, pretty much every automotive company or truck company, they are exploring with lighter, more compact engine and 3D printed parts. We even have 3D printed full cars, like the one on screen, that are really changing the way we conceive and we produce cars. We are applying this technology even to tires. Michelin and 5 joined forces to create a new kind of tires, and we see it's jumping to every field. Printable electronics is one of the most interesting parts too, because we're going to completely change the way we manufacture electronics. So we see many different applications, many technologies, many products, and now we're going to see a little bit of the market size, the manufacturer landscape, the competitive landscape. And these, I believe, is most important, the limitations that this technology currently has. So how many 3D printers are there in the world? Statistics found in Statia suggest that in 2016 there were close to 500,000 3D printers in the world. But by 2019, the number is estimated to grow to up to 5.5 million units worldwide. So we do expect a huge boom in these technologies. This is a report from Gartner describing the 3D printing industry forecast in billions. Consumer and enterprise 3D printed shipments are growing at 95.4, and revenue is growing up to 81.9 from 2002 to through 2017. So big changes here. And we see that Ultimaker continues to create space between himself and MakerBot to print, manufacture, distribution. We see that there is, a thriving competitive landscape with companies dedicating to manufacturing, to software, to 3D scan, to slicers, to materials, to 3D printing services. But I would say this technology is still to boom. It has not really exploded yet. I mean, it made it to the mainstream consumer adoption, but it's not really generalized. I mean, it's still in a deceptive phase for most of us and most of the industries yet. Why is that? Because of the limitations that 3D printed has, both at the domestic scale and realm, but also and especially at the industrial level. It's still very time consuming. It's limited to the size of a printer, and you can, for the most part, most of the 3D printed only print one material at a time. It's very expensive to implement at scale, and we still have some problems with the quality assurance and with the operator certifications. So we see limitations at the 3D printing, at the industrial level, and we also see 3D printing, limitations at the consumer level. I mean, this is pretty much what we do for now. But see, this is precisely what it's starting to change right now. And why is that? Because we are freeing the design capabilities. 3D printing will not be completely freed until we can make full use of the design capabilities, of the 3D printing capabilities, and that's going to come with a generative design. Okay, the generative design is this process by which design is automated. You add a little layer of artificial intelligence, and you get families of products, families of efficient designs, much more efficient designs, considering whatever variables you want, that will propose shapes much more organic, much more efficient than what we designers are capable of doing. So this technology is probably going to be the one that unlocks the full potential of 3D printed. What is next for the future of 3D printing? We talk a little bit about personalized nutrition, about food. See, right now we're going to be able to tell the 3D printing precisely what we want and what we need in terms of vitamins, in terms of supplements, in terms of additives. So we're going to be able to, at a very, very low cost, have exactly what we need for hospitals or for ancient people, or in general. But what other things are very interested and new? See, we are seeing that some of the designers, like Neri Oxman at the MIT lab, they're taking this technology to the very edge. They're combining the scanning with the digitizing, with the computing, with the sensing, and with the active performance monitoring. They're mixing materials to 3D print a completely new different approach to clothing and to wearable devices that are reactive, that are changing and mutating. And see, the future of clothing might go in that direction. We are seeing that mixed materials.
How soon do you see this? Sorry, you hear me?
Yes. I mean, these work that Neri Oxman is designing.
This last part that you talk about Neuralink. How soon?
Diego, this is not to you. Yes,
it's actually just the team close by, so you can proceed. Sorry.
Can you go ahead?
Yeah.
I didn't hear you.
Can you hear Hez? Can you hear
Yes.
Hez? Okay, perfect. It was actually the group close by talking, so you can proceed.
Oh, okay. All right. Yeah, mixed materials is something that is probably going to make a huge difference too, as we can just integrate everything into one finished material, into one finished device. We're going to be completing the process of 3D printing electronics and cars. I mean, every part of the car may be able to be printed. So once we have all of the mixed materials 3D printed, we will just see, the digital file come in and the car step out. We saw already one example of those at all the houses. So today you can 3D print a toy truck with rubber tires, metal chassis, clear plastic, or glass windshield in a single print. The next level of these is to 3D print a fully functional device with circuits and sensors and logic. Another very interesting future possibility for this is the additive and subtractive manufacturing combined. So it's not only adding material that we're going to be doing, but also subtracting, and that is going to, create this concept of the factory on a box, delivering 100 times speeds faster, CNC machining, additive layering, and even injection molding. It'll be all unified into boxes that will become the factory of the future. We also have this possibility of printing human organs and tissues. So, instead of having to wait for a transplant, you can just 3D print whatever part of your body you might need. Researchers have convincingly demonstrated that simple organs and complex tissues can be 3D printed already by harvesting our stem cells, multiplying them, and then depositing them into collagen scaffolding of the desired organ. This miraculous cell grow into a fully implantable functional organ. We'll probably have to give it 7 to 10 years for this, but we'll be in the business of replacing parts and organs that our body will not reject. And we also have this last concept of the 4D printing, which is 3D printing parts, 3D printing components in a way that will be reacting to variations of electrical stimuli or pressure variations or temperature variations and so on. So now that will be adding. Imagine your clothing, for instance. If it's 4D printing, it'll automatically open based on the heat temperature that you have in your body and so on. We also are already seeing application for this for the sports clothing and so on. So that was the biggest part of it. And I know I run. There's too much material. There's not too much time. But I would love if you had any questions or any further topic that you'd like to comment on.
Can I just start with a question? I mean, I was interested in the limitation of the 3D or 4D printed machine.
Yeah.
Do you have any, I'll say, any idea, any dream, any kind of crystal ball on when that set of limitation could disappear? I mean, is there actually anything that could address us for what will be actually the future?
Okay, so great. I think this is the most interesting question actually for this technology. We're mentioning that we are in the deceptive phase yet, and that's probably because see, you can buy a 3D printing at home for under $1,000, and you can start playing around with the design. But there is a huge limitation for the majority of consumers because they don't really master design. They can only download files and 3D print them directly. And even though the amount of files that are already existing is pretty big, you cannot adjust, you cannot tweak the files or the design to your specific need. And that's precisely what is changing now. Now you can start with the generative design and with the parametric design. You can just equalize designs. You can stretch them. You can combine them. You can breed them with other designs and really master the process of designing. Once you have that capability, then I think the 3D printing will be booming, especially, I mean, both for industrial and for consumer level, because that is actually going to allow us to do design in a completely different manner. I mean, see, one of the main benefits of 3D printing is that you can, as I said before, 3D print very, very complicated, very complex components, very complex shapes. But you have to master the ability of creating those shapes. So unless you can create them, you will not unlock the full potential of this technology. The others, the fact that it's time consuming, the fact that it's limited size and one material at a time, most of them are just temporary barriers. They're not structural barriers, in my opinion, for adoption. Did I answer your question?
Yes, thank you.
So my question is on the on the scale of it. What I get of this is it's pretty it's for the personal use, at least it's pretty individual specific, right? But how do you scale it from an industry? You gave an example of the car. So basically, there is some research which happens, and then there is a car design, and so kind of applicability from a scale perspective is what I was kind of just wondering.
Okay, so depending on what technology or what material you're 3D printing, you can just keep on moving the 3D printer. And for construction purposes, for instance, is what's happening already. So the limitations are soon going to be overcome. For other technologies, other materials, it's just a matter of incorporating on the design, and that you can do with the parametric design already, the modularity of the components too. So if you design in that way, there's no problem with scale, because you can always make sure that all of the components are going to be fitting. So for some, the problem is going to be for some very large, high quality components in which the quality assurance is a key component. But see, the cost saving of and the promise of these alternative design is so big that the nautical aerospace industries are paying very good attention to overcoming these barriers very fast. So I think there are many limitations yet, but I would say like maybe in the next year or so, I believe we're going to overcome most of them.
Okay.
Because if you think of most of the technologies we have, they also have the same limitation of size, or either at the production phase or the transportation phase, etc. So I don't think it's going to be a huge issue in the future. Were you all familiar with this technology?
Yes.
You were?
But it's changing quickly.
It is. It's really hard to have a full understanding of what's going on, because I mean, some of these information that I'm giving you just happened like 2 days ago. This example, which I believe is really the key to take home project, is this image by Autodesk. I would suggest you take a closer look to this example, because it's going to be completely game changer. I mean, they're already applying it to plane partitions, to many plane components. Because I mean, we're talking. See, I just work with a company in Mexico in the automotive industry, and a team of 5 people that were not experts on design downloaded one of these generative design tools and 3D printed a component without being experts, and in only 1 week they were able to reduce the weight of that component in over 15%. And that's a team that had absolutely no clue about 3D printing and no clue about design. So if they were able to do that, I mean, think of what we're not going to be able to see by the combination of the skills, very skilled designers and the generative AI design layers added into it. So we're going to see massive changes on the way we design and on the way we build things.
Yeah, I mean, to me, the implications for a port, logistics, carbon footprint, right? I mean, there's just so many possibilities if you think about that.
Can you show us the vendor slide? Is there one vendor that is leading the way?
The vendor? Could you please elaborate? I didn't get that.
All of the companies that you said are the leaders in the field. Is there one that's leading the way?
Yes. Give me just 1 second, please. So these are the manufacturers. Is that what you're interested in, or the applications?
The one with the logos, I guess, right?
What was that?
The one with the logos.
Yeah, the
okay.
manufacturing service design.
this one,
3.
Okay. Yeah, so here you see on the left the manufacturers with 3D scan technologies and printer technologies. And for 3D printed, you see the Ultimaker, Stratis, Formlabs. And those are, I would say, the largest ones, and then the rest comes. But see, the second and third position keep on changing constantly, so I wouldn't take these as a fixed image.
Okay.
Are we talking about the same technology principle or same processes, or is it actually still in the phase in which people are doing actually something completely different? I mean, I'm just referring as a sample as VHS and Betamax? I mean, is there a winning technology right now?
That's interesting.
Showing your age, man.
The thing is that there is different approaches to different materials and to different processes. And actually what is happening is that we're not going to be limited to beta or VHAs. We're going to see that we can do ad hoc development for this technology. I mean, you can 3D print chocolate, or you can 3D print, human cells. So depending on what you need, you're going to see that we're going to be able to do specific applications for our technologies. We start from these 9 basic technologies, but the most interesting part, as I said before, is the combination of them, not only of the 3D printing technologies, but of the materials and the additive and subtractive, etc. So I don't think there's a standards as per se, because you can just hack. You can change the material that you put in these 3D printing technology. You can change the accuracy of the printer. You can change the digital file, and you'll have a completely different solution outcome. Sorry.
I guess we're running out of time, so we should have been back to 2 minutes ago, actually.
All right.
So this was excellent. Thank you so much.
Thank you very much.
Thank you. It was really my pleasure. I hope I helped out.
I need a bio break. Please are welcome.
Zoo.
Thank you.
Thanks.
No worries. Sorry, just want to get it. They just want to go to one station.
Yeah, this is it. This actually is over now. So we're good. All right.